Hi students, I am Tanveer Malik. I am physics teacher. Today I will solve your IGCSE physics paper for May-June 2023. This is paper of May-June 2023 and code for this paper is 625, paper number 4 for zone 2. Question number 1 is, figure shows helicopter which is stationary at a height of 1500 meter above the ground. State two conditions necessary for helicopter to remain in equilibrium. So remember that when an object is in state of equilibrium, then it must satisfy two conditions for equilibrium. Two conditions of equilibrium are, number one, net force acting on a body is zero. If there is no net force acting on a body is zero, then body will be in state of equilibrium. For example, a book placed on a table. Net force acting on the book is zero. So it will be in state of equilibrium. This is first condition for equilibrium. And second condition for equilibrium is when there is no net turning effect. When no net turning effect, then body will be in state of equilibrium. So we have to write these two conditions. First condition is no resultant force. Since helicopter is in state of equilibrium, so no resultant force is, no net force is acting on a body. You can write no issue. No resultant force is acting on a helicopter. And second condition is no resultant moment of force. No resultant moment of force. When the body satisfies these two conditions, then it will be in state of equilibrium. Now, next is mass of helicopter is 3200 kilogram. Now mass is given. Calculate the change in gravitational potential energy of the helicopter as it rises from the ground to 1500 meter. Height is also given, mass is given. You have to find the gravitational potential energy. Change in gravitational potential energy equal to, formula for gravitational potential energy is mgh. So gravitational potential energy delta E, you can write P for potential energy. If you don't write, that's not an issue. You can just write GPE, gravitational potential energy. Mass is given 3200. Value of G is 10. And height is 1500 meters. You have to just multiply these. You will get the answer. And answer is 4.7, 10 is power 7. 4.7 multiplied by 10 is power 7 joule. This is your answer. So you can write 4.7, 10 is power 7 joule. This is of 2 marks. Now we'll move towards the next question. Next part is figure shows vertical speed time graph for a parachute who jumps from a stationary hot balloon. This is the graph, which is speed and time. Speed time graph is shown in the figure. Parachutist jumps from a balloon at time t is 0 and reach the ground at B. At the point A indicates when the parachute opens. On the figure, label the points on the graph where the acceleration is 0 with 1, negative with 2, decreasing with 3. So this figure is about a parachutist who jumped from a balloon. First, when he jumped from a balloon, its weight start increasing. It is moving under the action of gravity. This is the mass. Suppose when he jumps, then he is moving under the action of gravity. He will move with acceleration due to gravity. When any object, not a parachute, any object whose mass is m, it is dropped from a height, then it will move under the gravity, under the action of gravity, and its speed will be change in acceleration will be g. It will move towards the ground with acceleration due to gravity g. But when it is moving in downward direction, then its speed is increasing in every second. When its speed is increasing, then air resistance, which is acting in the upward direction, it acts on the object. Due to this air resistance, its speed start decreasing until a certain situation came when acceleration due to gravity become equal to the air resistance. Both become equal. When both become equal, then body will move downward with constant speed. When a body is moving with constant speed, then there will be no acceleration. If a body is moving with constant speed, then there will be no acceleration. Here, first speed is increasing in this portion. This is speed is increasing. Air resistance is acting. This is the, now acceleration is decreasing. At this point, it is moving with constant speed, no change in speed. When it reaches at point A, then he opens the parachute, due to which its speed suddenly decreases. Now it is decreasing. This is negative acceleration. Now it is decreasing. At this point, its downward force, which is under the action of gravity, and its upward force, which is air resistance, become equal, and parachutists move with constant speed. That means there is no acceleration. So there are two conditions. There are 2 points at which there is no acceleration. At one point is this, and second point is this. These 2 points, there is no acceleration. You have to mention these points as 1. This is 1. This is also 1. Second, negative with 2. Where acceleration is decreasing, you have to mention it as 2. Here acceleration is decreasing. Third is decreasing with 3. Where acceleration decreases, this line is straight. If he goes straight, since it is down this straight line shows the constant acceleration. This line shows constant acceleration. This is down the constant acceleration, this point. So this will be represented as 3. So here acceleration is decreasing. Here acceleration is negative. Now speed suddenly decreases. When speed is decreasing, then acceleration is negative. And at this point and this point, acceleration is constant. Explain in terms of forces the change in motion which occurs from when the parachutist leaves the hot balloon till point A. This is the point A. When parachute opens, you have to explain all forces. First, he will move under the action of gravity. Initially, gravitational force acts on it in downward direction. As the velocity increases, air resistance increases. When air resistance increases, acceleration decreases. When air resistance becomes equal to weight, then it moves with constant speed. This point, which is represented by A, that is the constant. So we will write this in detail since it is of 4 marks. So you have to write in detail. Question is, explain in terms of forces. You have to write the all forces which are acting on the parachutist. The change in motion which occurs from when the parachute leaves the hot balloon until point A. You have to explain all the forces which are acting on it till parachute opens. So, initially gravitational force acts downward. Initially, gravitational force acts downward. As velocity increases, air resistance increases. When air resistance increases, then its speed starts reducing. When air resistance increases, then acceleration decreases. When speed is decreasing, then acceleration is decreasing. Acceleration decreases. Acceleration decreases when air resistance becomes weight of the body. When air resistance becomes equal to weight of the body, weight, then it moves with constant speed. Constant speed. This graph is repeated many times in different ways. Sometimes graph is shown. Sometimes they ask write in detail when a parachutist jumps from a parachute. So in many years, this question is repeated in different ways, but concept is same. Whenever an object is dropped from height, first of all, it will move under the action of gravity. When it moves under the action of gravity, then its speed start increasing. When speed increases, then air resistance also increases. Speed is acting downward, weight is acting in downward direction, air resistance is acting in upward direction. So air resistance increases till weight and air resistance become equal. When weight and air resistance become equal, then body will move with constant speed. Next is this question is completed. Question number 2. Student catches a cricket ball. The speed of ball immediately before it caught it 18 meter per second. The mass of cricket ball is 160 gram. Calculate the kinetic energy stored in the cricket ball immediately before it is caught. Since ball is moving, so it has kinetic energy. You have to find this kinetic energy. Speed is given, which is 18 meter per second. Mass of the ball is also given, which is 160 gram. But 160 gram, you have to convert first 160 gram into kilogram. Since speed is in meter per second. So you have to convert mass into grams into kilogram. Mass is 160 gram. That's mean 160 divided by 1000, 0.16 kilogram. Speed is given. Now you can use formula kinetic energy equal to 1 by 2 mv square. So it becomes 1 by 2, mass is 0.16 kilogram, velocity is 18 square. By using calculator, you can find it will be equal to 26 joule. So your answer will be 26 joule. Next, this is very simple. It takes 0.12 second to catch the ball and bring it to rest. Now it becomes to rest. That means initial speed is 18 meter per second, final speed is 0. Since it becomes to rest, final speed V is 0. Initial speed, ball was moving with 18 meter per second. And time is given, T is 0.12 second. First of all, you will find acceleration. Acceleration is V minus U over T. V is 0, minus U is 18, T is 0.12. This is the negative acceleration since its velocity is decreasing. Calculate the average force. That's very simple. You have to use formula from second law of motion. F is equal to ma. Mass of the ball is given in the question. That is 0.16. Acceleration you have calculated 18 divided by 0.12. You can use negative. If you don't use negative sign, which is acceleration, this just shows velocity is decreasing. Negative acceleration means velocity is decreasing. You will divide and you can calculate its answer. That is 24 Newton. This is 24 Newton. So net forces or average force is 24 Newton acting on the ball. I have to clear every time, since when I does not clear it, then it will not move in upward direction. First of all, I will clear it. then I will stop annotation, then paper will move in upward direction. For every question, I have to clear C part. As a student catch the ball, she moves her hand backward. Explain the effect of this action on the student's hand. When ball is coming and student want to catch it, he moves his hand in backward direction. Why he is moving hand in backward direction? You have to give the reason. When he moves his hand in backward direction, time of ball to reach the hand increases. When the time increases, and you know that the rate of change of momentum equal to applied force. When time increases, then force which is acting on the hand become less and its hands does not hurt. So its answer will be, there would be longer contact time. Longer contact time. So it would be, so it would not hurt. So it would exert so ball would exert, you can write instead of it, you can use ball would exert less force on hand. Less force when less force is exerted, then it would not hurt. So hands would not hurt. Would not. Since when he pushes his hand in backward direction, then time increases. When time increases, then the force acting by the ball will be decreases. The reason is this, you know that rate of change of momentum, delta P over T equal to applied force. This is the no need to write this. This is just for your revision. Rate of change of momentum equal to applied force. That means force is inversely proportional to time. If you increase the time, then force will be decreases. If you increase the time, then force will be decreased. If you decrease the time, then force will be increased. So we move towards the next question. Again, I have to stop annotation.